Hello, good afternoon, students. Myself, Hiral Raval, Standard Ninth, subject Science. Today, in previous lecture, we have studied chapter number 10, Gravitations. We discussed some point, what is gravitations, then universal law of gravitations, and we discussed the scientist Isaac Newton's law. Then we discussed the Kepler's law, है ना. We solved some one examples 10.1. In last lecture, we have studied topic 10.2 free fall. Let us try to understand the meaning of free fall by performing this activity. Activity 10.2. Take a stone, throw it upwards. It reaches a certain height and then it starts falling down. We have learned that the earth attracts objects towards it. This is due to the gravitational force. Whenever object falls towards the earth under this force alone, we say that the objects are in free fall. Is there any change in the velocity of falling objects? Velocity में जो है वो changes होता है. While falling, there is no change in the direction of motion of the object. But due to the Earth's attractions, there will be a change in the magnitude of the velocity. Any change in velocity involves accelerations. Whenever an object falls towards the earth, an acceleration is involved. Acceleration जो है वो उसमें involved हो जाता है. This acceleration is due to the earth's gravitational force. Therefore, this acceleration is called the accelerations due to the gravitational force of the earth, or we say that acceleration due to the gravity. It is denoted by g. जो ग्रेविटी जो है उसको हम g से डिनोट करते हैं. ओके, एंड रिमेंबर द यूनिवर्सल कांस्टेंट g, ग्रेविटेशनल कांस्टेंट्स कैपिटल g. Value of the gravitational constant g is equal to 6.67 into 10 raised to minus 11. Okay, we write this g, gravitational force. Value of this force is 6.67 into 10 raised to minus 11 Newton into meter square upon kg square. Okay, this is the value of gravitational force. While falling, there is no change in the direction of motions of the object. The unit of small g is the same as that of acceleration. Unit जो उसका same है मीटर पर सेकंड स्क्वायर. We know from the second law of motions that force is the product of mass and accelerations. Let the mass of the stone in activity 10.2 be m. We already know that there is accelerations involved in falling object due to the gravitational force and is denoted by g. Therefore, the magnitude of the gravitational force F will be equal to the product of mass and accelerations due to the gravitational force. That is, F is equal to m into g. Okay, we put the value mg is equal to g m into m upon d square. So the value of g is equal to capital G m upon d square, where m is the mass of the earth and d is the distance between the object and the earth. Let an object be on near the surface of the earth. The distance small d in equation 10.7 will be equal to capital R, the radius of the earth. Thus, for objects on or near the surface of the earth, mg is equal to capital G m into m upon r square. This is already we discussed the gravitational force accelerations capital G. Here the another fractions are there. Small g is equal to g upon g into m upon r square. The earth is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. For most calculations, we can take g to be more or less constant on the near the earth. But for objects far from the earth, the accelerations due to gravitational force of earth is given by equation 10.7. Okay, so to calculate the value of g, put the value of m upon r square. Capital G, the value of capital G is equal to 6.7 into 10 raised to minus 11 Newton into meter square per kg square, mass of the earth. The value of capital M is equal to 6 into 10 raised to 24 kg, and the value of capital R is equal to 6.4 into 10 raised to 6 meter. Okay, so G, put the value of G, M and R square, we get G is equal to 9.8 meter per second square. Thus the value of accelerations due to the gravity of the earth is 9.8 meter per second square. Okay. The next topic 10.2.2, motion of object under the influence of gravitational force of the earth. Let us do an activity to understand whether all objects, hollow or solid, big or small, will fall from a height at the same rate. Activity 10.3. Take a sheet of paper and a stone. Drop them simultaneously from the first floor of a building. Observe whether both of them reach the ground simultaneously. We see that paper reaches the ground little later than the stone. This happens because of air resistance. The air offers resistance due to the frictions to the motion of the falling objects. The resistance offered by air to the paper is more than the resistance offered to the stone. If we do the experiment in a glass jar from which air has been sucked out, the paper and the stone would fall at the same rate. We know that an object experiences accelerations during free fall. From equations, these accelerations experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. According to a story, Galileo dropped different objects from the top of the Leaning Tower of Pisa in Italy to prove the same. As g is constant near the earth, all the equations for the uniformly accelerated motions of object become valid with accelerations a replaced by g. ओके उसने क्या किया, एक ही जगह पे g रख दिया. सो द वैल्यू v इज इक्वल टू u प्लस ए टी. वी कैन ऑल्सो राइट v इज इक्वल टू u प्लस जी टी. s is equal to ut plus 1 half at square. So we also write the gt square. Then 2as, so we also write 2gs. Where u and v are the initial and final velocities and s is the distance covered in time t. In applying these equations, we will take accelerations a to be positive when it is in the directions of the velocity, that is in the direction of motion. The accelerations a will be taken as negative when it opposes the motions. Example 10.2, a car falls a ledge and drops to the ground in 0.5 सेकेंड. कार जो है 0.5 सेकेंड के लिए स्टॉप कर दी है. ओके, जी की वैल्यू दी है हमें 10 मीटर पर सेकंड स्क्वायर. फॉर सिंप्लीफाइंग द कैलकुलेशंस के लिए हमें जी 9.8 की जगह पे हमें 10 दिया है. सो व्हाट इज़ द वैल्यू, व्हाट इज़ द स्पीड ऑफ स्ट्राइकिंग द ग्राउंड, स्पीड फाइंड करनी है. व्हाट इज़ इट्स एवरेज स्पीड and how high is the ledge from the ground. Okay, so first of all we all write data. Okay, सबसे पहले क्या हमें डेटा लिख देने हैं. टी हमें फाइंड करना है. इनिशियल वेलोसिटी यू ज़ीरो होगी. एक्सीलेशंस होगा जी 10 मीटर पर सेकंड स्क्वायर. एंड एक्सीलेशंस ऑफ कार ए जो है वो डाउनवर्ड्स में है तो ऑब्वियसली 10 मीटर पर सेकंड स्क्वायर. सो फर्स्ट वी हैव राइट द स्पीड v is equal to 80. So v is equal to 10 into 0.5. Okay, 10 into 0.5. 0.5 means के 5 upon 10. 10 10 cut. So answer is 5 meter per second. Okay. Now topic 10.3. Now average speed. Average speed. Equations of average speed. U plus v by 2. Here u 0. V 5 upon 2. So answer is 2.5. 5 upon 2. 2.5. And distance travelled as 80 स्क्वायर है ना. वैल्यू रख देनी है, पुटअप कर देनी है तो आंसर मिलेगा 1.25. ओके, दिस इज द 3 आंसर्स. देन 10.3 अगेन एग्जाम्पल्स. ओके, डिस्टेंस दिया है, v की वैल्यू दी है, g दिया है और a दिया है. ओके, पुट दिस वैल्यू एंड सॉल्व द एग्जाम्पल्स. ओके, इल्यूस्ट्रेशन दिए ही है, आपको खाली सॉल्व करना है. मैथमेटिकल पूरा फॉर्म है. ओके, टॉपिक 10.3 मैथ्स. We have learned in the previous chapter that the mass of an object is the measure of its inertia. We have also learned that greater the mass, the greater is the inertia. It remains the same whether the object is on the earth, the moon or even in outer space. Thus the mass of an object is constant and does not change from place to place. mass जो होता है वो place to place जो है वो change नहीं होता है. Okay, then we conclude weight. We know that the earth attracts every object with a certain force, and this force depends on the mass of the objects and the accelerations due to the gravity. The weight of an object is the force with which it is attracted towards the earth. We know that F is equal to m into A, that is F is equal to mg. The force of attraction of the earth on an object is known as the weight of the object. It is denoted by W. Substituting the same in example equations of 10.4. So we have write W is equal to m into g, as the weight of an object is the force with which it is attracted towards the earth. The SI unit of weight is the same as that of the force, that is Newton. The weight is a force acting vertically downwards. It has both magnitude and directions. We have learned that the value of g is constant at a given place. Therefore, at a given place, the weight of an object is directly proportional to the mass, say m, of the object, that is W into m. It is due to this reason that at a given place we can use the weight of an object as a measure of its mass. The mass of an object remains the same everywhere, that is on the earth and on any planet wherever its weight depends on its locations. Topic 10.4.1 Weight of an object on the moon. We have learned that the weight of an object on the earth is the force with which the earth attracts the object. In the same way, the weight of an object on the moon is the force with which the moon attracts the object. The mass of the moon is less than that of the earth. Due to this, the moon exerts lesser force of attraction on object. Let the mass of an object be m. Let its weight on the moon be Wm. Wm means के mass of weight of the moon. Mass of the moon be m into m. And the radius be Rm. So we can write universal law of the motion applying this equation. Wm is equal to G m into m upon Rm square. Let the weight of the same object on the earth be We. The mass of the earth is capital M and its radius is capital R. Okay, from equation 10.9 and 10.15 we have We means के weight of the earth का equation मिला G into m upon R square. So Wm, put the value of these equations. So Wm mass weight of the moon हमें मिलेगा 2.431 into 10 raised to 10. यहाँ उनका रेशियो दिया है तो रेशियो अप्रोक्सीमेटली हमें 1/6 मिलता है. ओके 1/6 ऑफ इट्स अर्थ वेट ऑफ इट्स अर्थ वेट ऑफ द मून इतना होगा. सपोज हमारा जो वेट है तो अर्थ पे हमारा वेट 48 है तो 48 अपॉन 6 8 जार 48. तो वेट ऑन द मून हमें मून पे हमारा वेट कितना महसूस होगा 8 kg. ओके तो हम हल्के फुल्के जंपिंग करते रहेंगे. ओके मून पे जाके हम जंपिंग करेंगे. ओके यहाँ पे एक एग्जांपल दिया है. मास ऑफ m 10 दिया है. सो W इज इक्वल टू m इंटू जी. W इज इक्वल टू 10 इंटू 9.8. सो आंसर मिला 98 न्यूटन. और यहाँ पे रेशियो दिया है WE अपॉन 6 तो 10 अपॉन 6 तो हमें आंसर क्या मिलेगा 1.67. Thus the weight of object on the surface of the moon would be 1.67 Newton. Okay, here the inbuilt questions. Then 10.5 thrust and pressure. What is thrust and pressure? Have you ever wondered why a camel can run in a desert easily? Why an army tank weighing more than 1,000 tons rests upon a continuous chain? Why a truck or a motor car has much wider tires? Why cutting tools have sharp edges? जो टूल्स होते हैं उसके एज क्यों शार्प होते हैं? In order to address these questions and understand the phenomena involved, it helps to introduce the concepts of the net force in a particular direction. Thrust. This is the definition of thrust, and the force per unit area is called a pressure acting on the object concerned. Let us try to understand the meanings of thrust and pressure by considering the following situation. Situation number 1. You wish to fix a poster on a bulletin board as you shown in the figure 10.3. To do these tasks, you will have to press drawing pins. Okay, हमें drawing pins चाहिए with your thumb. You apply a force on the surface area of the head of the pin. हम head पे pressure करते हैं. This force is directed perpendicular to the surface area of the board. This force acts on a smaller area in the tip of the pin. हम छोटे से बोर्ड से पूरा जो है वो ब्लैक जो पोस्टर है वो लगा देते हैं. ओके देन अनदर सिचुएशन number 2. You stand on a loose stand. your feet go deep into the sand. Now lie down on the sand. You will find that your body will not go that deep in the sand. In both cases, the force exerted on the sand is the weight of your body. हमारा body का जो weight है पूरा हम उसके sand के अंदर चले गए हैं. You have learned that the weight is the force acting vertically downwards. Here the force is acting perpendicular to the surface of the sand. The force acting on the object perpendicular to the surface is called the thrust. So this is the definition of thrust. When you stand on loose stand, the force that is the weight of your body is acting on an area equal to area of your feet. When you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. Thus, the effects of forces of the same magnitude on different areas are different. In the above cases, thrust is the same, but effects are different. Therefore, the effects of thrust depends on the area on which it acts. The effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called the pressure. So here the definition of pressure. Pressure is equal to thrust upon area. Substituting the SI unit of thrust and area in equations, we get SI unit of pressure as Newton per meter square or Newton into meter square minus 2. In honor of scientist Blaise Pascal, the SI unit of pressure is called a Pascal. Unit of pressure is Pascal and denoted by PA. Let's consider a numerical examples. Okay, ये जो सारे examples हैं ना वो omit हो गए. Okay, 10.6 मैं आपको बता देती हूँ. 10.6 omit है. ओके ये वाला एग्जाम्पल्स है वो जो ओमिट हो गया है. ओके नेक्स्ट वीडियो में हम 10.5.1 से हम स्टार्ट करेंगे. ओके स्टूडेंट, तो ये वीडियो में मेरे टोटल 2 क्वेश्चन है. व्हाट इज़ थर्स्ट एंड व्हाट इज़ प्रेशर. ओके स्टूडेंट, थैंक यू.